So I'm going to go over the questions that were in your book work that was due August 27th, and it's from sections 1.1 and 1.2. The only question I asked, or I gave you for 1-1 was number 27, and I tell you what I'm going to do with this. I'm actually not going to talk about this one at all. Over the course of the semester, I'm going to ask that you guys do presentations. And what I'll do is I'll present ideas or questions or areas of research that you can look up and do. I'm not looking for term papers. I'm looking for you to do something so that you can do like a 5 or 10 minute presentation to the class that covers the subject. And in this particular case, it's Russell's paradox. What you would need to do is to put together some kind of presentation, either just you talking or a video or a PowerPoint presentation or something that you can do, on screen, since that's where we are at the moment. And also then provide to me a list of your sources. So everything would have to be sourced. You'd have to have more than one source. I would hope that you'd have, let's say, 3 sources, and Wikipedia does not count as a source. 3 sources other than the textbook, things that you read, things that you incorporated into your presentation. What I'm going to do with this is say the first person who messages me after hearing this and says, I'd like to do this, will get to do it. And then after that, we'll see if I can come up with another way of assigning things to you, or maybe we'll just let you guys figure out what you want to do as we go along. But for now, that's what we'll do with this one. So if that interests you, send me a Schoology message, and we'll go from there. For 12 and 13, statements given, write the negation of the statement, and then which is true, the given statement or its negation. Okay, so we already know that if you're doing a universal statement, if you have a universal statement and you're doing the negation, it's going to become an essential statement. So for all real numbers x, 2x plus 4 is greater than 0, and the negation would be there exists a real number x such that 2x plus 4 is less than or equal to 0. I would think that there's a bunch of real numbers that would make 2x plus 4 less than or equal to 0. And the first one I can think of is -2, which would make it equal to 0. So there you go. All men are mortal. There exists a man who is not mortal. I'm not going to go near the question which of the two is true, because I think that sort of gets into questions of religious faith. So I'm just going to chicken out and move on. Multiple choice. Give the negation of no one under 21 can legally buy alcohol in Illinois. What would it take to negate that? Well, there would have to be someone under 21 who can buy alcohol in Illinois legally. All people under 21 cannot legally buy alcohol. That actually says the same thing. All people under 21 can legally buy alcohol in Illinois. That's not really the negation. You don't need all people in order to negate that. Some people under 21 cannot legally buy alcohol in Illinois. It's still not doing it. Some people under 21 can legally buy alcohol in Illinois. D is the one that would prove the original statement false. No one under 21 can legally buy. Well, some people under 21 can legally buy. That would be the negation. And then no one under 21 cannot legally buy alcohol. That would mean that all people under 21 can legally buy. And that's not it. So D has to be the right answer here. In 15 and 16, you're given a set. And then a statement is given. Write the negation of the statement, and then which is true, the statement or its negation, and justify your answer. So 15, for all n in S, n is less than 11. And the negation would be there exists an n in S such that n is greater than or equal to 11. And the negation here is true because 11 is part of the set. So there does exist an n in S such that n is greater than or equal to 11. 16, there exists an even integer m such that m is in S. And then I guess the negation would be for all m in S, m is not an even integer. And I think that negation is true here because there are no even integers there. 17, consider the statement there for all real numbers x, there exists a real number y such that the tangent of x is equal to y. Write the negation of this statement. It's kind of easier to think of this as what does this really say? And what this says is no matter what real number you come up with, you can take the tangent of that number. And so you got to ask yourself, well, is there a number that you could put into tangent of x is equal to y where there wouldn't be a y for an answer? Is there any number for which the tangent is undefined, that there is no answer? Yeah, there is. The real number that we're thinking of, and of course you can't use degrees for that because they're not really real numbers. The real number in this case would be pi over 2 because pi over 2 doesn't have a tangent. It's undefined because it's a vertical line. Tangent is slope, and a vertical line has an undefined slope. So the negation of this statement is there exists a real number x such that there is no real number y to make tan x equal to y. And that's true because the counterexample would be pi over 2. Let's see, 18, multiple choice. Consider the statement triangle ABC is isosceles. Which of the following is the negation of this statement? The negation would be a triangle ABC is not isosceles. Isosceles means it has two sides that are the same. Right triangle, well, that has to do with angles. Equilateral triangles are all isosceles. Obtuse triangles can still be isosceles. It's scalene triangles. Scalene means none of the sides are equal, so that would be the answer to that one. The negation of this statement is ABC is a scalene triangle. And again, it's one of those things where you're saying to yourself, well, somebody comes to you and says triangle ABC is isosceles. You want to go, no, it's not. And I can prove it. How can you prove it? Well, look, it's a scalene triangle. Okay, number 20, multiple choice. If t is a real number, which of the following statements is true? For all t, the cosine of t is equal to 0. That's not going to be true. There's lots of things that don't have a cosine equal to 0. But there does exist a t such that the cosine of t is equal to 0. Actually, there's more than one. The cosine is equal to 0 when t is pi over 2. For number 20, you only have to come up with one counterexample in order to prove that a universal statement is not true, or in the case of B, in order to show that there exists something, you only have to come up with one. For number 21, here's a list chart of a bunch of things, and the question is true or false? For all students S in the sample, S participates on some sports team. So let's see, we've got all those sports teams, and for each person, there's a check mark in there somewhere. So I guess A is true. Some foreign language club has no members. Okay, so that means we're looking for a column with nobody in it. There's the Spanish one. That's true. There exists an academic club C such that for all students S in the sample, S is a member of C. Where are the academic clubs? Oh, here we go. Yeah, they're all members of the math club. So that one's true. Okay, D, for every category, there is some club which has no members in the sample. Okay, for every category. So we've got 4 categories. In the sports, nobody's a basketball player. Foreign language, nobody speaks Spanish. Fine arts, nobody's in chorus. Academic clubs, nope. There's somebody in each one of those 3. I only need to have one counterexample. So for D, the counterexample is the academic clubs. E, every student in the sample is a member of some club in each category. Well, let's see. We got 1, 2, 3. Oh, wait a minute. Aiko is not a member of the Fine Arts Club. So I guess that disproves E. Okay, the last one here, multiple choice. You learned in geometry the measure of an angle inscribed in a semicircle is 90 degrees. Which of the following statements is not equivalent to the one above? All angles which are inscribed in a semicircle have a measure of 90 degrees. That's the same thing. If angle A is an angle inscribed in a semicircle, then the measure of angle A is 90 degrees. That's the same thing. For all angles A, if angle A is inscribed in a semicircle, then the measure of angle A is equal to 90 degrees. I think that's the same too. Every angle which is inscribed in a semicircle has a measure of 90 degrees. I think they're all equivalent, aren't they? Yeah, every angle which is inscribed in a semicircle has a measure of 90 degrees. Those are all the same statement. So there you go.